Conic sections, kids, these are amazing.
Yeah, totally.
Because if you take an ice cream cone and put it on top of another ice cream cone,
Like
get
a
that out of the
waffle.
way. Yeah,
Like
yeah,
a
like a waffle cone.
Waffle over waffle.
Yeah, and then you
Like
take
this.
a plane, like a sheet of paper.
Yeah.
And you
just
make
cut
some
it.
slices.
Yeah.
You get all these different shapes.
Yeah, so what in this first one, and it may be hard on your note packet to really tell what's going on. This first one,
That's a parabola
that's
shape.
a parabola. If you look at just like the small different color, that's a parabola. These two, if it's like a perpendicular situation to the cone, then it's a circle.
Right?
But if it's slanted,
if it's a little tilted,
it'd be an ellipse. And then this one right here is a hyperbola. And in Algebra 2, I believe
you're
go
forgetting
over
one
these.
too. If you go right down the side of the cone through both cones, that's a line.
Right, these are...
And if you go through the very middle where the cones touch, that's a point.
That's true.
We can get all of the different types of ways to graph basically in 2D from this. I think that's fascinating.
It is pretty cool. So we're going to, during Chapter 8, look at these different kinds of conic sections. And the three ones we're going to focus on are the parabola, the ellipse, and the hyperbola. And there is actually kind of another one, the circle, but we just are going to talk about ellipses, and if it's an ellipse that it goes out the same way both directions, then it's a circle.
Right.
But
so
we're not going to make
we'll pull
new
that
rules
in
just
as
for
part of our discussion.
Right. So we're starting off in 8.1 with a parabola. A parabola is the set of all points in a plane equidistant from a particular line called the directrix and a particular point, the focus in the plane.
Now, before we go and have a panic attack about all this directrix focus business, a parabola is still a parabola that you learned about in Algebra 1.
Like y equals x squared?
Yes.
Still the same deal.
Still the same deal.
We are kind of complicating it a little bit more because we want to know actually what's going on.
We want to define how it does this.
Right. And so what happens is you have the vertex we should be really familiar with. It's the bottom point, and it creates this symmetry on either side, this axis of symmetry that's in green here. And then the two things we may not be as familiar with are the focus is over here inside of our parabola. So if it's facing up, it's inside.
It's like the point that the parabola lines bend around.
Right. And so, and then the directrix here is going to be somewhere below that, like on the opposite side of the focus.
And it's the exact same distance from the vertex to the directrix as it is from the vertex to the focus.
Right. So like if this was a 2 here, then it would be 2 here.
Right.
That's happening. And I'm trying to remember, like, what happens is, and you can find cool applets to do this, like this point right here should be the same distance if we go here and we go here.
Right.
Like, there's these cool applets that maybe we can show at
I'll
some
see
point
if I
that,
have something on my computer. Maybe we can screenshot it and talk about it.
Yeah, yeah.
Okay.
So, like that should be the same. Like, if this was 5, this would be 5.
Right.
That's the same distance, and that's how the parabola actually gets drawn.
Right. Very cool.
Yes. So, and that different stuff is all in there. So the axis of symmetry here, it's called the focal axis.
Because it runs through the focus.
Yeah. So let's look some more. Let's
do
what's going on next.
Oh, looky here.
All right. So let's first start off talking about parabolas with vertex 0, 0. When we talked about parabolas at the beginning of the year, we were only talking about functions, which are y equals some sort of x squared.
Right.
And now we're talking about all parabolas, so they might not be functions, which means we could have
x
y squared.
Yeah, we could have y squared or x squared or some sort of
combination. Not combination. That wouldn't be a parabola.
Not yet. Wouldn't be a parabola. Okay.
So our standard form for our equations is we can have x squared equaling, and we have 4py, which p we'll talk about in a second. Or we could have y squared equaling 4px. And so depending on which term is squared, that's how you know if it opens up or down.
Right.
And then the sign actually will tell us whether, of those two things, whether it's up or down.
Yeah,
because
exactly.
if we had like x squared equals negative something y, then that's going to be going down.
Right.
And if we had x squared equals positive something y, it'd be going up.
up.
So the focus, we can figure out, basically, if we can figure out what this p-value is, that tells us where our focus is located, and depending on which kind of equation is which
way
place
you
we
move.
put it. And then the directrix can also be found using that. So
and the directrix is a line. So in case you didn't catch that on the first picture,
slide.
it is a line.
It's like y equals or x equals.
Right.
And then the axis, if we're at 0, 0, is going to be the y-axis for the first one, the x-axis for the second one. and it'll move whenever we don't have our vertex at 0, 0. So P in all of this is our focal length, and so that P is, we might later on be able to see what that P value is later on when we're graphing.
But that's the distance from the focus to the focus.
Focal width.
Vertex to focus. That's the focal length.
Okay, and then the focal width, let's go back to this, the other picture. The focal length we're saying is how far it is from the vertex to the focus?
Right, because the focal width is the distance through the parabola, through the focus, from side to side.
So I can't really get rid of what I have, but
Right.
let me change colors here real quick. So our focal width would be if we took the line that goes through the focus.
Right, and it started on parabola, it goes through the focus, stops on parabola.
Right.
That's your focal width.
And then our focal length would be this 2 here that I had drawn.
Right.
That right there.
Yeah.
All right, so let's do, for example, 1. Find the focus, directrix, and the focal width of each parabola. Well, all 3 of those things revolve around knowing what P is. So that's where we should start, right?
Yeah, got to start with P. Now, I would say also, maybe where it has the standard equation, an alternate way to show that would be to divide 4P on both sides. And then you actually have the equation you would use to graph.
Right, so we could
instead
look
of saying
at
x squared equals 4py, we could say 1 over 4py times x squared equals y.
You mean 1 over 4p equals x squared. You
Yeah.
put a y in there that wasn't supposed to be in there.
Oh, sorry. Yes.
So he's saying we could have 1 over 4p x squared equals y.
Right. If
Okay?
we wanted.
And it all depends on like which kind, like what your formula is. Because like this, we need to just compare this. X squared equals 4py. That's our standard form. They gave us x squared equals 8y. So what does 4p equal?
4p has to equal 8.
It does, because this and this have to match. So set 4p equal to 8, and that means that p is 2.
The deuce.
Yeah. So if p is 2, now we can go in and plug into our table and figure out what the focus, the directrix, and the focal width are. Keeping in mind that because it's x squared, we're going to use this first column the whole time. So our focus is going to be 0, comma p, which is 0, comma 2.
Right. So that's how far the focus is from the vertex.
Our directrix
Goes the other way now.
Y equals negative p.
Negative 2, yep.
And then our focal width.
Would be 4 times that.
And it's in absolute value. So if we had a negative situation, then we would take the negative away. Because we're just talking about a distance.
Just a distance.
So 4,
and we already had 4p,
4p,
it's 8.
so
Like
it's
that was
8.
where we started.
Yeah. So this right here is our answer. And I abbreviated those, and you can feel free to as well, unless we run into something where we can't abbreviate.
Right.
Which I don't think it should be
I don't
an
think
issue.
that's going to happen here.
So let's do part B. So this is
Oh,
where...
by the way, the x squared, that one's going to open left, right.
Yes. No. X squared opens up and down.
Oh, that's what I meant. The next one opens left, right.
Yes, this one opens. So, and if we write the second equation, like he mentioned, where it's x equals, then we'd have 1 over 4p y squared equals x. And that may make more sense for this equation, because look at what we've got. We've got negative 1/6 y squared. So if we compare this, we're comparing negative 1/6 and negative 1 over 4p.
Right.
So...
And in this case, the ones are equal to each other, so we really just need to set the denominators equal.
Right.
Negative 6 equals
Or
4.
cross multiplying will give you the
Or,
same thing.
yeah, or cross multiply.
Whichever. So negative 4p equals 6. Or you put the negative on either side of
Doesn't
that.
matter,
Doesn't
because
matter.
it's going to wind up only on one side at the end.
So p equals, if we simplify, negative 3/2. 6
Right.
over 4 is 3/2. So now let's plug those in, and now we're using the second column because we have x equals, not x squared.
Right.
And so which way would this open?
So I believe this is going to open to the left.
Right, because that's the negative direction
That is
for
correct.
x.
Right, and the
and
p,
we've got a negative.
our p actually moves negative 3/2. So if that focal point is what the curve bends around, and it's on the left-hand side of our
vertex,
of our
which
vertex,
is at 0, 0,
which is a
then
0,
yeah,
0,
it
then
has
it's got to open to the left.
So our focus is negative 3/2.
0.
0.
Yep.
And then our directrix again, we're just plugging into these values on our table. So a negative p, negative 3 halves.
Would be positive 3 halves.
Got a little change action going on there.
Click, click. And then 4p is actually where we started.
Right.
So that would just be 6.
4p would be, well, it's 4 times negative 3 halves with the absolute value, right?
Right.
Which is
6.
6. Right. Because that's 12 over 2.
Right.
Okay.
12 over 2 or 2 times 3. And remember, with focal width, it will never be negative because it is a distance.
It's a distance.
Just like if we were to get in our car, it doesn't matter if we drive in reverse or if we drive in forward, the odometer will only roll up.
So then should our focal length be an absolute value as well, or because that's
No,
a
because
distance?
yeah, but the focal length, we need to know which direction to go so that we know which way our curve bends.
Okay.
So that has to be negative.
Okay.